morning, grade 10s. Welcome to a video on where we're going to discuss trigonometry, and we're going to take it up onto the Cartesian plane where we have the x values, y values, and how can we use the trigonometry inside the Cartesian plane. All right, so first of all, I tried to explain to my class how the cast diagram was formed. I don't know if your teacher did that for you, but we did that and then discovered that in the quadrants, so if we have our different quadrants, if we call this quadrant, let me just abbreviate it, quadrant 1, this one would be quadrant 2, going anti-clockwise, quadrant 3, and quadrant 4. Then we discovered that different trig ratios are positive in different quadrants. So with that, we discovered that over here, the cos was positive. Here, all of the trig ratios were positive. Here, the sine graph or the sine ratio was positive. And here, the tangent was positive. So they were all positive over there. Conversely, you have then that the others were negative. So if you see them not there, then we can take it here that tan and sine was negative. Over here, cos and sine was negative. And over here, that tan and cos was negative. Let me just erase that positive because maybe that confuses some. Just looking at so tan and cos, let's represent it like that. All right, is negative. And this is how the cast diagram was created. To check where they were positive, we just took a very easy triangle, 3, 4, 5 trigonometric ratio, right angle triangle, and we went and we drew it in every part of the Cartesian plane. Also remember that on this side, the x is positive. If it's on this side, on the left-hand side of the Cartesian plane, x is negative. At the top, the y would be positive, and at the bottom, the y is negative. So if you think of a Cartesian plane, you always used to draw it like this. 2, 3, 4. Here would be -1, -2, -3. 1, 2, 3, and at the bottom, -1, -2, -3. All right, so it's exactly that Cartesian plane that we're using. I think sometimes students forget what we actually like talking about or referring to, but that is the cast diagram, and that is what we're going to use to identify in which quadrant we are working at. So the following sums are where you have to, with the aid of a diagram and without the use of a calculator, you need to find the value of a specific ratio, trig ratio. All right, so let's quickly have a look what those questions look like. All right, so the hint here is that they will say to you it's without the use of a calculator and with the aid of a diagram. All right, then we know, all right, we have to draw onto the Cartesian plane where, in which quadrant it would fall, and then we have to work out the other side that is not given with Pythagoras. Then we're going to replace all our x, y, and r values, and then we're going to be able to find out what the value is of tan theta plus sine theta. So first of all, we're going to concentrate over here. Let's get a nice bright color. And then we're going to say cos theta is, if cos theta is 4/5. So cos we know as is adjacent over the hypotenuse. So the a value is 4 and the hypotenuse's value is 5. But before we get to that, we have to say 4/5 is a positive ratio. So we know that cos is positive. And we say that it's actually, the restriction here is that it has to be between 0 and 90. Theta's size is between 0 and 90. That's what that means. So without actually having to use the cast diagram, but let's just write it up nicely. There's the cast diagram. Then we know that those ratios are positive in these 4 quadrants over there indicated. So if we had to look, cos is positive over here and over there. So we could have drawn it in quadrant 1 or quadrant 4. But now they tell you, because it's between 0 and 90, we know then that it is in quadrant 1. So we're going to use that, and we're going to draw up our triangle over here. That over there we indicate, oopsie, I changed my thing there. We indicate as theta. Put a little arrow there. And then we know cos is the adjacent. So if that would be your 90 degree, the 90 degree always goes down to the x-axis over there. All right. So if you had to draw it over there, it will look like that. If you had to draw it there, it will look like that. If you had to draw it in the fourth quadrant, it will look like that. Okay, let's just take that away because it has to be in the first quadrant, sorry. So now we know it's the adjacent. So if this is the hypotenuse, that is the opposite. This would be the adjacent, which is 4. The hypotenuse is 5. Okay, but if you have this on the x and y value, the x and y axis, can you see that this value over here from there to there is given that it's 4? Okay, so that means the x value is 4. This one, because it's, if you had to draw a circle around, I'm just going to draw it quickly, around that triangle, we call this the radii, the ray. So that 5 is the ray. So I'm just going to put it as x. 5 is the ray. And we are always looking for x, y, and r. Okay, x, y, and r. The opposite, the hypotenuse, and the adjacent. Okay, not necessarily in that order. So we are looking for the y value. Can you see that if you had to draw a line like that, that would represent the y value. So we are looking for the y value. Okay, so we've got x is 4, r is 5, and we're looking for y. And if you can see, it's very easy to see that this is a trig, a beautiful trigonometric ratio, trig ratio, a Pythagorean triangle, there's the word. And then y would be 3. Okay, y, 3, 4, 5. You could have also worked it out. You're going to say 4 squared plus y squared is equal to the radii squared. So 16 plus y squared is equal to 25. So y squared is equal to 9. Then you would say y is equal to plus minus 3. Because if you have 3 squared, it will give you 9. But as well as if you have negative 3 squared, it will always also give you 9. So now you need to go and see, is the y value at the positive side? Yes, it is. So y is a positive 3. You don't have to put the positive over there, but it will be a positive 3. So please always, once you find your answer, the answer will always give you two values. It either is a positive or a negative. Then you have to go back to your Cartesian plane, and I always say look at where the y is lying. Is it at the top value or is it here at the bottom? Then that will give you the value of the y. Very important, one thing that I forgot here, you have to always write Pythagoras. So over here, if you could see the Pythagorean triangle and you just want to say Pyth over there, that's perfectly fine. And then what I do to make it stand out is I put it in a big hearty always. I always say do the hearty right up. And then we can go back now because we've got our x, the y, and the r values. And now we can go look at what has been asked. Okay, I'm going to get to that now. So I just want to show you the other ratio that we learned. So if you put sine, cos, and tan over there, sine is opposite over adjacent, cos to go and see the band, and tan is maniki tanning. Okay, so katoa, there's lots of ways to remember that. So katoa, or you can say it's a sin to say cos to go and see the band. I don't know if you know that. Tan is a maniki tanning like that. So if you have his hands like that. All right. Another way to remember the trig ratios is shade your rear, cos x raise tan your exterior. I'm just going to write it here. Shade your rear. So sine is y over r, cos x rays tan, cos x rays tan your exterior, like that. So shade your rear. So it's sine is y over r, cos x over r, tan is y over x. All right. So another way of remembering this. So now we go back to what is asked. Tan theta plus sine theta. So tan theta plus sine theta, that was originally what was asked. And now we're going to go to our ratios. Tan's value is y over x. So theta. Sine by itself means nothing. Cos by itself means nothing. So tan theta's value is the same as y over x. So we're going to go look here. Y is 3 over x, which is 4. So tan theta's value is 3 over 4. And that's how we worked it out now without the use of a calculator and with the aid of a diagram so that we could know that. And sine theta, shade your rear. So it's 3 over 5. So shade your rear because x-rays tan your, just want to make sure that I'm right, your exterior, which is 3 over 4, and sine shade your rear is 3 over 5. And then you are more than welcome to go pop that into your calculator. There, we don't care if you use your calculator or not. So 3 over 4 plus 3 over 5 gives you 27 over 20. And you can leave your answer as a fraction form. All right, let's look at another example. So first step is we need to simplify our equation over here. All right. Is equal to 0. I've made a mistake here. Let me just rewrite that quickly. So they say to you, if 8 tan theta plus 15 is equal to 0 and theta is an element of 90 to 270, determined with the means of a diagram. All right. So first steps first, we're going to simplify our equation. So 8 tan theta is equal to, so can you see if you throw that over first, negative 15, then you divide by 8. So tan theta is equal to negative 15 over 8. So we want to see in which quadrant we're going to draw our diagram. Very important. So if you have your cast diagram over here, and they say to you that tan is negative. So tan, can you see your value here? That's why your solving of your equation is very important. If you throw it over and you don't put it in negative 15, then everything is wrong. So where tan is a negative is over here and over there. All right, why? Because tan is positive over there and there, which means the other two would be where tan is negative. But they also say to you that the theta ranges between 90 and 270. So if you've got your degree signs here, 0, let me do it in another color. You would have 0 degrees, 90 degrees, 180 degrees, and 270 degrees, and then a whole one would be then 360 degrees. So let me go back to my color again. So they say to you it ranges between 90 and 270, which means that it would be either in this quadrant or this quadrant. So where's the overlap happening? You guessed it, quadrant 2. So we have to draw our triangle in quadrant 2. So the ray down to the x-axis 90 degrees. Always indicate theta from the beginning of the 0 degree from the x-axis. Please, it always goes. And later on when you do the trig graphs, you'll see why you can do that. Why it's always not the inverse, but where you subtract that will actually give you the same as that theta angle over there. But we'll get to that. So this would be your 0 degrees. So you've got your x, your y, and like that. Okay. Then originally they said to you tan theta. So shade your rear because x-rays tan your exterior. If you want to see it as tan is opposite over the hypotenuse, you can gladly, opposite over the adjacent, Okay, so over here, this would be negative 15. Does it make sense that the y is there, negative 15? No, so the negative doesn't belong to the 15. So it's going to be 15 over negative 8, I'm sure. Does it belong to the x? Yes, it does. Why? Because it's on the negative side of x. So just always make sure that that negative is actually standing in the front, and it can either belong to the 15 or the 8. So which one does it belong to? So with that, we have to find the r. So we've got x is negative 8, y is 15, and r, with the use of Pythagoras, I'm going to say 15 squared plus negative 8 squared. Remember that negative 8, if you square it, it's going to give you a positive 64. So it will always give you a positive answer. 289 for r squared. So r is going to be plus minus 289, the square root of 289. No. Sorry, I'm doing something wrong. It won't give you a plus minus. Let's just write it up in the Pythagoras style. So negative 8 squared plus 15 squared will give you the ray squared. Okay, so that's 64 plus 15 squared gives you 225. It does give you a positive. Positive negative. Okay, plus 64 gives you 289. So r squared is equal to, let someone take the square away already. So r is equal to plus minus the square root of 289. But because it's a ray, it's always a positive. And the square root of 289 gives you 17. Okay, a beautiful 17. So that's another nice Pythagorean triangle triplet. 8, 15, and then 17. Now we've got r as well. R is equal to 17. And then I'm going to put it nicely that it stands out. We've got that. We've indicated our pi. We've got it in the correct quadrant. Sorry, we indicated our theta sign. Very important, people. That's a mark over there. We worked it out. We wrote Pythagoras. So far, you should have 4 marks together. Okay. Then we're going to move on. And we're going to look at what they actually asked us to do. So sine theta plus cos theta. Am I right? So yes. Okay, so sine theta is shade your rear. So it's 15 over 17 plus cos theta, cos x rays. So it's negative 8 over x rays over 17. So 15 plus minus becomes a minus 8, which gives you 7 over 17 like that. Again, you're more than welcome to put that in your calculator. We don't worry about that. So it's subbing it and answer. So 4, 5, 6. And the last 2 marks, 34 sine theta minus 17 cos theta. So 34 times the sine theta, shade your rear, which is 15 over 17, minus 17 times cos theta, cos x rays, which is negative 8 over 17. And this will give you 30. Again, you are more than welcome to pop that in your calculator. And a minus 17 times negative 8 over 17, which gives you minus 8 if you put that in, and you get 30 plus 8, which gives you a beautiful answer of 38. And over here, I think that will count a little bit more. I would say 1, 2, 3, 4, 5, 6, 7, 8, 9 marks in total. So quite a bit of work. And when I set my exams, you always get one like this in the July exam, and you always get one in the November exam. All right, I hope that makes sense. Please, just a quick reminder to please indicate your theta sign, your theta angle over there. Oopsie, as well as to write Pythagoras, and then please, we don't, sine theta falls away after this. What is the value of sine theta? With the aid of your diagram, it gives you 15 over 17. Lots of my students want to go and write sine theta is equal to 15 over 17 and try and move on from there. Yes, that is that, but then replace it and drop away your sine theta. Okay, all right. I will make a few more of these examples after this video. The students in my class said, ma'am, you must keep your videos shorter. It's too long. So I'm going to try and make shorter videos all over the place. But after this, I'll explain to you one where it's in terms of K, or in terms of a certain number. You don't have a value, but you can work it out in terms of, and that's more of grade 11 work, but it's good for you to have a look at it and and understand it, because I'm sure you will be able to. All right. Thanks so much for listening. Have a wonderful day. Bye-bye.